Hey, what's going on, everyone? So, we are going into Unit 11, Lesson 7 today. I hope you guys all had a awesome Mother's Day weekend. I know the weather wasn't the greatest, but hopefully you were able to spend some time with your family and do something, I guess. It looks like everything's going to be starting to clear up within these upcoming weeks. We can only hope. According to Cuomo, you could start going out and gardening as of the 15th because apparently you were not allowed to do that from now, I guess. So, definitely interesting. Let's see here. I see some people are just kind of jumping in here and there right now, so I'll wait for a few more to start popping up. Yep, I do that every single time, Sierra. Every single time. I have been beating Sylvia with my net on my island for 2 weeks, and she still won't leave. But Sydney, the koala, she was out. She just walked up to me. She says it wasn't doing it for her, so she left. No, I haven't started yet, Shannon. You're okay. I was just waiting because it was showing that there was only 4 people on, so I think some people were stuck with ads. So I am just waiting a little bit, seeing if there's a few more that are going to be popping in before I actually start teaching the lesson. Everybody else have a nice weekend at least? Let's see here. Thank you, Shannon. It was a fun one. Not only was it my birthday yesterday, obviously it was Mother's Day, and I was born on Mother's Day, so that's always a special day for me and my mom. But it was also my wife's parents' wedding anniversary. So it was a pretty crazy day yesterday. So we were celebrating Mother's Day for my sister-in-law and my wife's parents down in Fredonia. Did my birthday. We didn't do anything big. We just had like a steak dinner and had some birthday cake, and that was about it. But yeah, thank you for all the birthday wishes, guys. There's not much you can do when you're stuck in your house, to say the least. So, between eating some steak dinners, I pretty much came home and played some video games, and that was my night. But, anyways, so I hope everybody had an opportunity to download this. Today's lesson is really just an extension on what we did last week with the graphing. So, we're still going to be doing stuff with the calculator. I'm going to show you guys some like little tips and tricks that you can do without the calculator. So like as you guys can see right at the top of the page, I have the letters A, B, C, and D. Um, Everything that we're going to be doing are shifts, and the shifts were kind of similar to what we did back in like unit, what would that be, unit 7, when we did all the transformational shifts, the stretches, the compressions, all that kind of stuff is on repeat. We're just going to be doing it with trig functions. So some of you guys may be slow at it at first. We can always do it on the calculator. We always have that option. I have to show the shortcuts though, because some of you guys are going into pre-calc, and pre-calc you are not allowed to use a calculator for half the stuff you are taught. So if you're going into math 12, for the most part you'll be able to use the calculator, so you won't be too bad as far as that goes. Okay, we'll kind of go with it. Yeah, Sierra, if you stop by, I'll help you out, of course. So I'm going to start right off at the top, and the first one I'm going to start with is the letter A, because we already talked about A. That was part of lesson 6. A just stands for the amplitude. So if you guys were to look at the two y equals that I have set up top, I have one that says y equals and says A sine B theta plus C. And then it's plus D after all that. I also have y equals A cos B theta plus C plus D. So the only difference between both of these functions is one of them has sine in it. Oh, I thought it was on. pencil. One of them has sine in it, and the other one has cosine in it. It's the only difference. All the letters are still going to mean the same thing. It's just based on which trig function you are using. So the first one is amplitude. That is the leading coefficient. And we said the other day that the amplitude helps determine the range. And this is how I should say it. I don't want to say determines the range. I'm going to say, because there's going to be something else with range that we're going to talk about today. So I'm just going to say that this does a stretch or compression to the function. So if you were multiplying it, and this is what we talked about the other day, if you multiplied it by the number of 5, then it got stretched out to 5. If you guys did a multiplication by 1/2, then the graph shrunk down. And if you were to look at the notes that we did from the other day, you would see that's what kept happening. The next one we didn't really talk about the other day. We'll talk a little bit, I think, on the second page. Nope, I'm going to talk about it in the whole next lesson. So we're not even going to do letter B today, but I'll introduce you guys to what letter B is. Letter B is known as the frequency. And frequency, just like in regular English, is how many times something occurs. So in this case, we're looking at how many times the curve repeats. Because we talked about sine and cosine, when we draw it out, it will keep repeating the same exact numbers forever and ever and ever. You can, Tabitha. If you just want to write it in normal colors, you can. I'm just color coding so I can match it up with the letters. That's all. So frequency is just how many times the curve repeats. So if you were to look at the curve down here, and I'm going to talk about, I'll wait before I get down there. So now we have C. Now, we talked about C earlier this year, and if you guys notice that C on both of these are occurring on the inside of the parentheses. Now, C is not something we're going to do with trig, but I still want to introduce it to you guys so you know what it means, because it's actually the same thing as we did earlier this year. We said if something happens to the inside of the parentheses, we called that a horizontal shift. So that just means the graph is going to move from left to right, or left or right. And a horizontal shift, we said if it ever happens on the inside, it's really the opposite sign. So if it was +5, it really means that it was moving to the left. And I'll put both of these down. So if it's positive, it really means it's going left. And if it's negative, it really means that it's going right. You guys may remember that from when we did transformations. And then the last one, so horizontal goes left to right. The only other one that we have to worry about is vertical. So the vertical shift was always on the outside, and that's just going to tell you if it's going up or down. And sign stays the same. So I'm going to show it to you guys with the calculator. I'm also going to show it to you guys by hand, especially this next question, because this is a good one to do by hand. I didn't color code my D, so I'm going to make sure I color code that plus D on here. So now, exercise number 1 says that we have f of theta is equal to sine theta plus 3. Now it says determine the transformation that occurred in f of theta and then graph the new function on the grid provided. So I'm going to do it by hand first, and then I'll show you guys what we did on the calculator last week. So first of all, I want to know what type of transformation happened. So the curve I already drew for you. It's already on the graph. This is sine theta. So sine theta is already drawn. Yes, Sierra. Yes. So if I have sine theta already given to me, I just need to know if I'm looking at this up here. I always pick highlighter when I don't want to. If I'm looking at that up there, what type of transformation do we have? Well, we notice the only thing that's different between sine theta and sine theta plus 3 is that plus 3. And if you guys look at this, the plus 3 is occurring on the outside of the parentheses. So if it's on the outside of the parentheses, this is a vertical shift. So it says determine the transformation that occurred. We actually are doing a vertical shift. And since it's plus 3, that just means we're going up 3. Because it's positive and the sign stays the same. So now this is without the calculator. Because we know it's going up 3, what I can do is I can go to every single point that was on the original graph. And when I look at every single point, I'm just looking at where it hits the line. So you guys are seeing all the little purple dots that I'm drawing in. And now, because we have it on the iPad, I'm going to use the scissors tool. I'm going to select all those dots, and the shift is up 3. So I am just going to count up 1, 2, 3. And then what I'm going to do is I'm just going to draw in that same exact curve. Oh, my iPad wants to do a straight line. And that's it. We're done. So the reason why I'm showing it by hand is because now we don't have to type all this stuff into the calculator. You could save a little bit of time. Again, I know a lot of you guys aren't going to feel comfortable doing that. So I am going to put the calculator up. I'm going to go through the same steps that we did the other day just to make sure you guys feel comfortable. So I'm going into the calculator. I'm going into y equals. I still have a graph typed in here from the other day. So I'm just going to clear it out. And I'm going to type in sine. Your calculator doesn't have theta on it, so you're just going to use x. And then plus 3. Before we go into the table, make sure that your calculator is in degree mode. Oh, I'm sorry, radian mode. Radian mode. We want to be in radian because if you guys look at everything that's on our graph, we have negative 2 pi, negative 3 pi over 2, negative pi. Those are all in radians. So my calculator is already in radian mode, so I'm okay. And now I'm going to go to table, and I have a bunch of stuff in there from the other day. So I'm going to delete those out by just hitting the delete button, the DEL button next to the left arrow, because I always want to start fresh. So the first thing I want to type into the calculator under Ask X, and I should probably show that one more time. If you have a bunch of numbers on there and you need it to show up, you can hit second table and make sure at the bottom of your window, the bottom of your calculator screen, it says ask. If it doesn't say ask, then you won't have a table that looks like mine. It's a vertical shift because sine is equal to y, or did you do something else? Sierra, look at where that plus 3 was located compared to what we did up top here. So if you look at the original function I wrote up top, the plus d is on the outside of the parentheses. So that means that d is equal to a vertical shift. So it doesn't matter that this is sine. It could have been cosine. It doesn't matter. This plus 3 is always going to be a vertical shift because that d is on the outside of the parentheses. that 3 is on the outside of the parentheses. So it's similar to what we did earlier this year, is if a number is on the outside at the end, it's always going to go up or down. And we'll do another one underneath. We're going to do another one that's going to be very, very similar. So now what I'm going to do is I'm just going to type in everything that's on our graph. So the first one I'm going to type in is -2 pi. And it says that the answer is 3. Now if I check my drawing, you guys should see at -2 pi, we did go up 3. So now I'm going to type in the fraction -3 pi over 2. And it says that answer is 4, which is exactly where my dot is. And I can keep doing this for every single one, and you guys will notice that all of those dots will match up. So if you feel more comfortable doing it with the calculator, that is completely fine. The reason why I'm trying to show it to you guys by hand is mostly for the people next year that are going to be going into pre-calculus. Because when it comes to JCC pre-calc, you need to be able to do this by hand, because on the test, you do not get the calculator for it. So as long as you know your vertical shift rule, you'll be okay with that. All right, I got one more graph that I want to show you guys. So we're done with that question. That's done. We just drew in, I should probably label it before I go down. This is sine theta plus 3. So the next one I'm going to do is 2 cos x plus 1. Now, just because there's an x there, you can use theta, okay? I'm okay. So Ella, you can use the calculator. If you want to use it, you can. It's just more or less I'm saying don't use it because I want you to practice without. So I am okay if you guys want to use the calculator. It's just for, I'm just trying to be a little bit more specific when it comes to pre-calc next year. Yeah, everybody can use the calculator if you want to, but if you can see the trick on how to move it without, life is a little bit easier for you. Okay? So first of all, I want to draw the cosine curve. So before I even do 2 cos x plus 1, I'm going to do this without a calculator, and then we're going to talk about the transformations. Now, I know you guys don't have this memorized yet, and that's okay. But cosine, if I were just to draw a cosine graph, cosine x starts at 1. So this is something we wrote down in the notes on Wednesday. So what I'm going to do is I'm going to put a little dot on the y-axis at 1. No, you guys do not have to memorize them. It's preferred if you guys can start remembering these, but you don't have to memorize them because you guys will always have the calculator. So cosine curve starts at 1, and what the cosine curve does is it goes down. And what we did the other day is we said that the numbers always alternate between 1, 0, and -1. So because this is a positive cosine curve, this is what I want to draw as a positive cosine curve. It's going to open up like a cup. So I know my curve is going to go from 1 down to 0, down to -1, back up to 0, and back up to 1. So again, you guys could type that all into the calculator and get that answer. The reason why I drew this one out is to show you guys what this kind of looks like, to help you guys remember what type of curve this is. And I know it's very, very hard to see this, but it's a little trick that I use when I teach it. This is a cosine curve. It's only the positive side of the cosine curve. But this curve looks like the letter C. And it's like a sideways C. And that's why I said it looks like a cup, because a cup starts with the letter C. So when I drew this out, I know it's a cosine curve because it's going to look kind of like a sideways C. The same thing happens when we do sine up here. Now I drew the sine for you in this graph, and I'm just going to look at the positive side. But I know it's not a perfect looking one, but what I just highlighted in red kind of sort of looks like an S. So if you see a squiggly that looks like an S from the y-axis all the way to the end, that is known as a sine curve. If it kind of looks like the C and it starts all the way from there to the end, that would be known as your cosine curve. Again, you can get all this when it comes with the calculator. I'm just trying to show you guys some tips and tricks without the calc. Now the thing is this graph, I only did the positive side with you guys. We still have to do the other side. We have to do the negative side. So if I want to do the negative side, I just have to follow the same pattern because the pattern repeats over and over and over again. So on this side, it's going to come down to -1. And then, I'm sorry, 0. And then -1. Then back up to 0. Then back up to +1. And you guys should notice it's a reflection. It's the same exact graph. It's just on the other side. Okay? So what we're going to do now is we're going to change our graph based on the transformations. So this function has 2 transformations. So it says explain the, I'm going to letter B first because we're doing it by hand, and then we'll go back to letter A so we can use it with the calculator. So in letter B, it says explain the transformations that occur in the function. Well, we have 2 numbers here. We have the +1, and we also have that +2. So if you don't have them memorized, which I don't expect you guys to have them memorized, but if you look back up to what we have, I've been color coding them. The 2 is at the beginning, so that is known as your amplitude. So we just have to figure out, does that 2 mean it's being stretched or compressed? Well, if you're multiplying something by 2, it's going to get bigger and it's going to start being, you can't see the bottom of my hand, but it's going to be pulled apart. So this is going to be stretched. So it says explain. The first thing that we're going to explain is we're saying this is being stretched by 2. And the other thing that's occurring is that +1. And very, very similar to what we just did in the last one, the +1 is on the outside of the parentheses. So if it's on the outside of the parentheses, that just means that we have a vertical shift. And since it is +1, we know we're going to be doing a vertical shift up 1. So what I'm going to do now is I'm going to go onto my calculator. I'm not going to do this one by hand because I showed you guys, we now know what this is by hand. We can do all this by hand. It's just, I know a lot of you guys are going to prefer the calculator. If you did it by hand, then you'll have the opportunity to check to see if you did it correctly. So what I'm doing is I'm deleting everything that's in the table because I don't want anything that's there. I'm going to y equals. This function is 2 cos x +1. And now I'm going into the table and I'm going to start typing in my numbers. So I'm only going to type in the one side. I'm going to type in all those negatives. So the first one I have is -2 pi. And it says the answer to that is 3. So I'm going to go up. I'm going to put a dot at 3. Now I'm going to type in the next one, which the next one is -3 pi over 2. And it says that answer is going to be 1. So I'm going to put a dot right there. The next one is at -pi. That's going to be down at -1. So it's overlapping that last graph. Then I have -pi over 2, which comes out to be +1. And based on the little pattern that we have going here, you guys might be able to guess that the last answer is going to be at 3. So, Sierra, because there's 2 steps, you would have to do both steps separately. Yep. So, since my first number was at 1, so if I come over here and I look at this number right here, the first step says to multiply by 2. So if you guys are at 1 and you multiply it by 2, the answer is 2. If we follow order of operations, the next thing we have to do is add 1. So if I do 1 times 2, that is 2, plus 1 gives us an answer of 3. And now I can just keep repeating those steps. So now I'm at 0. Well, 0 times 2 is 0, and then 0 plus 1 is 1. So that's how you do the math off the top of your head. I'm just showing you guys with the calculator because it's a little bit easier. So now down here I'm at positive 1. Well, negative 1. Negative 1 times 2 would give us negative 2. But then we would have to add plus 1, and it brings us back up here to that negative 1. And it's just going to keep occurring like that. Now, again, I only did the one side. I'm not typing the other side. That was an awful curve. I'm not typing the other side into the calculator because I want you guys to recognize that when we're working with sines and cosines, they just repeat forever and ever and ever. So the highest point that we have here is going to be at that 3. The lowest point is going to be at negative 1. So now I'm going to draw the other side, but it's going to go back down. It's always going to be reflected over that y-axis. So now I'm over at positive 1 again. It's going to go down, down to negative 1, back up to positive 1, all the way back up to positive 3. So this curve is just going to continuously repeat forever and ever and ever and ever. Okay? So there's one other thing that I have to talk about with you guys, and it's more specifically about this green function, but we'll talk more about it tomorrow. Part C says give the equation of the horizontal line that is equidistant from the maximum and minimum values. So I'm going to look at this green function. I'm going to draw on 2 lines. I'm going to draw on a line up here because that is the maximum height. I'm also going to draw on a line down here because that is the minimum height. And we talked about both of those in the last lesson. We said that's how you find the range. So the range is the highest value and the min is the lowest value. So in this case, it's between negative 1 and positive 3. That would be our range, the highest and lowest y values. Now, it says give the equation of the horizontal line that is equidistant. Let's find a color I haven't used. Let's do this weird greenish color. So we want to find something that is equidistant from the max and min. So we have to find the line that's in the middle of them. So you're just kind of averaging it out. What I'm going to do is I'm going to draw a line, and I know that this line is going straight down the middle. That green doesn't really come up very nice, does it? Maybe I'll do like this purple, and I'll make it a little bit thicker. There we go. So that line is right in the middle of the max and the min. So the line that's in the middle of the max and the min, we just simply call that the mid line because it's the middle line. It's probably the one vocabulary word in math that will make the most sense. I wish more math vocabulary was like this. So midline is just the middle line between the min and the max. And they just want the equation of that. So it wants to know, hey, what number is that purple line going through? And that purple line is going through positive 1. But it's an equation. So are we setting it equal to the x value or the y value? And in this case, it will be the y value because it's going through the y-axis. something that I want to point out, that y equals 1, y equals 1, y equals 1. It's because we're only going through the x. We're not going through the x-axis when we draw that line. We're going through the y-axis. It is a horizontal line, but it's not going through the x, so we have to say it's y equals. Now, the cool thing about this, and we'll talk about it tomorrow. I mean, I think it's cool. You guys won't think it's cool. But this part up here that says +1 is that answer down here. So that number, that vertical translation, the vertical shift in trig is known as a midline. So anytime you guys hear me use that word midline, all you have to do is look at the number that you are adding or subtracting at the end. We're going to talk a lot more about that tomorrow on the second page. And you can even see when I go down exercise number 3, part A says state the midline of both functions. So we're going to talk more about the midline. We'll talk more about graphing them. And then we will do some without graphs, and we'll just solve it algebraically. Okay? So that's all I got for today. I know, again, a lot of the lessons you guys are going to notice for this next week or two is just a lot of vocabulary. And it's because we're going into a topic that you guys have never done in math before. Trigonometry and graphing trigonometry is brand new, brand spanking new. So it's okay if you guys are a little lost when it comes to some of this stuff. Just give me a heads up if you guys have any questions, and we'll go from there. Okay? So I hope you guys all have a great rest of your day. I know it's still raining out. I want to go out and grill. I don't know if I want to grill in the rain, though. We will see. But awesome. Have a great one, guys. Yeah, that's it. See ya.